to prove the winning strategy of the Fibonacci name game. First, to prove the Fibonacci name game, we need to introduce something. First, we need to introduce the Fibonacci number system. For example, I will give a Fibonacci sequence 1, 2, 3, 5, 8, 13, and so on. Because it's a sequence, so every number of it has a position 0, 1, 2, 3, 4, and extra. The Fibonacci number system is just like the binary number system. In binary number system, for example, 1, 2, 1, 1, 0, 1, 0, 1, 0. Every position of it stands for one number. If the position if the value is 1, it then the number in that position. If the number is 0, then the decimal number is 0, so it should be 1, 0, 4, 0, 16, and the total number should be 16 plus 4 plus 1 is equal to 21. So it's the same as the Fibonacci number 10101. The first stands for 1, second 0, third 3, 4, 0, 5, 13. The total number should be 30 plus 3 plus 1 is equal to 17. But we need to mention that because of the definition of the Fibonacci number, every number is equal to the addition of the formal two number. For example, 80 is equal to 3 plus 5. So there's a property of the Fibonacci number system is that there will not be two consecutive ones. For example, if the number is 1101, because the definition of the Fibonacci number, we could plus this one and it's equal to 10001. So in that case, we have the definition that Fibonacci number system will never have two consecutive ones. Now let's prove the Fibonacci name game. First, as we all know, the name game. To prove a name game, we need to follow two steps. First one, if it's at a safe state, no matter how many stones you pick, it will turn into an unsafe state. And if it's an unsafe state, follow the proper definition, follow the winning strategy, we can make it to a safe state. It's an unsafe state. We can make it to a safe state. That's the definition. That's the basic winning strategy. So what about the Fibonacci name game? Fibonacci. In Fibonacci name game, we suppose X is the number of stones we can move in this turn. and F is the rightmost one in the Fibonacci number. For example, if the number is something like this, and the F is rightmost one is this one, it should be equal to 1, 2, 3, 5. It should be equal to 5. So the winning, so our definition for safe state is that if a game is at the safe state, we the x means the number of stones we can move, is always smaller than the F. It's always smaller than the rightmost one in a number. And the unsafe state is that the number of stones we can move is bigger than the rightmost one in a number. So if we prove the first step and the second step through many steps, through first one and the second one, the number of Fibonacci, the Fibonacci number will finally goes to 0, and we need to make sure that we are the last player to pick the last stone. Let's first prove the first step. From a safe state, we can any remove action from the safe state will make it unsafe. For example, the first given number of Fibonacci, the first given number is something like this. It's a Fibonacci number, and if it's the first step, by the definition, we can remove any number. So x is, suppose the Fibonacci number is n. The x is smaller than n, and at this time the rightmost one is this one, and it stands n, and x is smaller than n, so this is a safe state. At this time, any move from the any move action will make it unsafe. For example, we will our move should be x, and we can send this like as a subtraction titles. 1 0 0 0 1 0 0 0 0. These two are Fibonacci number. This is the original one. We don't know the execute 0 of it, but we can just think about the rightmost one, so it's not the problem. And for the x, let's first think if there's 1 in it. If there's 1 in it, it will become 2. The remaining part will be like this, and it's very obvious that the rightmost one will be rightmost one is this, and it stands for the f will be smaller than the this is the last times f will be smaller than x, so it's an unsafe state. This is the specific situation. The right side of the x is not only 0, but it has 1. Now let's consider if there's only 1 in the right side. So the answer will be 0, 0. The remaining part will be like this, and the rightmost one is this one, f, and the last step we remove is this one. This is the last x, and this is last f. Okay. This is last f. If we multiply 2 by x here, we will get the x of this time, and you can see that because of the position of the x here and the f is they're just one distance, so it's in fact it stands for fx and fx plus 1. So let's in this condition we just need to calculate the difference between 2 multiply fx and the fx plus 1 by the definition of Fibonacci number. We know that fx plus 1 is equal to fx plus fx minus 1, and fx is equal to fx minus 1 plus fx minus 2. So fx is bigger than fx plus 1. So fx plus 1 minus fx is smaller than fx. Fx plus 1 is smaller than 2 multiply fx, so x is bigger than f, so it's an unsafe state. We consider the two conditions. The first one is there's 1 behind the leftmost one, and it's definitely an unsafe state. And if there's only 1 in the only left one in there, the remaining part will be like this, and f is still smaller than x. It's an unsafe state. So we prove that we can under the safe states we can make it unsafe. Second one. Second, we need to prove that from an unsafe state we can make it through our winning strategy. We can make it safe. So just as the principle we lastly improve. As unsafe state is that f is smaller than x, and so for example, one zero one zero one 0, 0, 0. This is f and smaller than x. Our winning strategy is that we just need to remove f number of stones. So we make s is equal to f, and the remaining part is 1 0 1 0 0 0 0 0. Since the last time the remove stones is f, so this time the stones we can remove is 2 multiply f. 2 multiply f. X is little smaller or equal to 2 multiply f, and this time the new f is equal to this one. It's the 2 position upper the original one. So this time we need to judge the relation between this one and this one. So we need to judge the relation between fx plus 1 and fx minus 1. We suppose this position is s plus 1, this is x minus 1. Fx plus 1 is equal to fx plus fx minus 1. Fx is equal to fx minus 1 plus fx minus 2. So fx minus 1 is smaller than fx. So fx plus 1 minus fx minus 1 is bigger than fx minus 1. So we can conclude that fx plus 1 is bigger than 2 multiply fx minus 1. So this time f is bigger than x, which is equal to less than f. So we conclude that if we are in an unsafe state, through our winning strategy, which is remove the rightmost number of stones in the number, and the whole number will finally get to a safe state. So that's the proof of the Fibonacci name game in normal case. For the Fibonacci name game in uneuro case, which means that the given number is random. You are randomly given a number, which may be like this. And since you are the first player to play this game, so you just need to remove the rightmost part. This time is at an It's we don't know. Oh, it's at it's at a safe state. Oh. No. This time it's at an unsafe state because the rightmost one is this one, and f is definitely smaller than x. Because x you can remove is this one minus 1. So this is an unsafe state. And through the winning strategy, you just remove this one. It becomes 0, 0. And just follow the definition. We are now safe. We are now safe again. You just follow the definition, and it will go through step 2, step 1, step 2, step 1. So the difference between normal case and normal case is just the start point. In normal case, the start point is the safe state, and in a normal case, the start point is unsafe state. So the proof will be the same. That's the proof for the Fibonacci game.